Welcome to another lecture video on series. In the previous lecture, we learned about a series test which can determine whether a particular series is divergent or not. As a reminder, we cannot use the divergence test to show that a series is convergent. So our study for today is on convergence tests, specifically for series of non-negative terms. A series of non-negative terms is of the form summation of a sub n, where a sub n is greater than or equal to 0 for all n. Let's take a look at some examples of series of non-negative terms. Our first example is the series given by summation from n equals 1 to infinity of 2n over 1 plus n squared. Tingnan natin kung bakit non-negative ang terms nitong series. Dahil n greater than 0, it follows that 2n is also greater than 0. Moreover, yung 1 plus n squared greater than 0, kasi n squared ay palaging non-negative. Kaya pag dinivide natin ito, 2n over 1 plus n squared is greater than 0 for all n. Ibig sabihin lahat ng terms ay hindi negative. Another example is given by the summation from n equals 1 to infinity of 2 to the n sine squared n over 3 to the n plus 1. Kagaya nung naunang example, kapag even ang exponent, halimbawa ang sine squared n, palagi itong non-negative. Tandaan din natin na 2 to the n greater than 0 at 3 to the n greater than 0 for all n dahil positive ang kanilang base. Ibig sabihin, ang 2 to the n sine squared n over 3 to the n plus 1 is greater than or equal to 0 for all n. Ngayon naman, tingnan natin ang ilang examples ng series with negative terms. For the first example, we have the summation of negative 1 to the n minus 1 over n factorial. Malinaw dito sa example na kapag n equals 2, ang second term ay negative 1 over 2 factorial, which is equal to negative 1/2. Another example, we have the summation from n equals 2 to infinity of cosine n over ln n. Sa unang tingin, mukhang non-negative ang mga terms nitong series. Pero hindi ito totoo. Tingnan natin ang first term when n equals 2. Dahil 2 is greater than 1 at ln ay increasing, it follows that ln 2 is greater than ln 1, which is equal to 0. Yung cosine 2 naman, dahil yung 2 radians mas malaki sa pi over 2, pero mas maliit sa pi, ito ay nasa second quadrant. Therefore, cosine 2 ay negative. Kaya cosine 2 over ln 2 is also negative. We now proceed with our first test for series of non-negative terms. We call this test the integral test. And the integral test is given by the following theorem. Let f be a function that is continuous, positive valued, and decreasing on the interval closed bracket k, comma infinity, for some k in the set of natural numbers. Suppose that f of n equals a sub n for all n in the set of natural numbers, such that n is greater than or equal to k. Given these conditions, the following two possibilities may happen. First, if the integral from k to infinity of f of x dx converges, or in other words, has a real value, then the series summation from n equals k to infinity of a sub n converges. On the other hand, if the integral k to infinity f of x dx is equal to infinity, then the series summation n equals k to infinity of a sub n diverges. As a reminder, before using the integral test, we have to check if our function f satisfies the three conditions, namely, f must be positive valued, f must be continuous, and f must be decreasing on some interval k to infinity. Usually, we choose k to be the smallest value of n in the given series. Let's take a look at some examples that use the integral test. The problem is to determine whether the series given by summation of 2n all over 1 plus n squared converges or diverges. As stated in our theorem, pipiliin natin yung function na f such that f of n equals a sub n. In this case, f of x equals 2x over 1 plus x squared. Napakita natin kanina na f is positive on the interval bracket 1 to infinity. Alamin natin ngayon kung bakit continuous si f. Note that f is a rational function and rational functions are continuous everywhere except at the points where the denominator is 0. Pero sa example na ito, ang 1 plus x squared ay palaging greater than 0 for any value of x. Kaya f is continuous, in particular in the interval 1 up to infinity. Kailangan din natin i-check na f is decreasing on the interval 1 to infinity. Para mapakita ito, kukunin muna natin ang derivative ni f. As an exercise, you can show that f prime of x is equal to 2 times 1 minus x squared all over 1 plus x squared quantity squared. Note that the denominator of f prime is greater than 0 for any real value of x. Yung sa numerator naman, for all x greater than or equal to 1, 1 minus x squared is less than or equal to 0. Kaya f prime is less than or equal to 0 for all x greater than or equal to 1. In other words, f is decreasing on 1 up to infinity. Since all of the conditions for f are satisfied, we can now apply the integral test. We now compute the integral from 1 to infinity of 2x over 1 plus x squared. First, we rewrite this improper integral as the limit where t goes to infinity. Gagamitan lang natin ng u sub na u equals 1 plus x squared, kaya du equals 2x dx, at ang makukuha na integral ng du over u ay ln u lamang. Evaluating ln of 1 plus x squared gives us the limit as shown in our slide. Madaling makita na ang limit nito ay positive infinity dahil constant lamang si ln2. By integral test, ang conclusion natin ay the series diverges. For our second problem, we want to determine whether the series summation from n equals 2 to infinity of 1 over n times quantity ln n squared converges or diverges. Again, ang first step natin ay isulat ang function f of x equal to 1 over x times ln x squared. Madali lang ulit ipakita na f ay positive valued, continuous, at decreasing on the interval 2 up to infinity. As an exercise, subukan niyong isulat ito ng maayos, kagaya nung ginawa natin sa naunang problem kanina. Pagkatapos nitong conditions, pwede na natin gamitin ang integral test. We now compute the integral from 2 to infinity of 1 all over x times quantity ln x squared. Again, isulat ang improper integral as the following limit. Tapos, gamitan lang ng u sub na u equals ln x para ang makuha na integral ng 1 over u squared ay equal lamang sa negative 1 over u. Evaluating from x equals 2 to x equals t gives us the following limit. This limit goes to the real number 1 over ln 2. Thus, by integral test, the series converges. Before we solve our third problem, i-define muna natin ang P series. Let P be a positive real number. A P series is a series of the form summation from n equals 1 to infinity of 1 over n to the P. Our goal in this problem is to find all values of P for which a P series converges. Ihiwalay natin itong problem into two cases. For case 1, suppose P equals 1. Then the P series is just the harmonic series, summation of 1 over n. At from previous lectures, we know that the harmonic series is divergent. Kaya hindi kasali ang P equals 1 sa sagot ng ating problem. For case 2, we suppose that P is not equal to 1. Again, isulat natin ang function f of x equal to 1 over x to the p or x raised to negative p for x in the interval 1 to infinity. Madali lang ulit ipakita na f is positive at continuous sa interval 1 to infinity. Moreover, f is decreasing on the interval 1 to infinity, since f prime of x equal to negative p times x raised to negative p minus 1, which is always less than 0 for any x on the interval 1 to infinity. Dahil na-satisfy ang conditions ng ating theorem, pwede na natin gamitin ang integral test. We now compute the integral 1 to infinity of 1 over x to the p dx, where p is not equal to 1. Isulat muna as a limit as t approaches infinity of the following integral. At dahil p not equal to 1, ang integral ng x to the minus p ay x to the minus p plus 1 over minus p plus 1. Evaluating from x equals 1 to x equals t gives us the following limit. Take note that for 0 less than p less than 1, ang term na minus p plus 1 ay positive. Kaya ang makukuha nating limit ay papunta lamang sa positive infinity. Kapag p greater than 1 naman, yung negative p plus 1 ay less than 0. Kaya ang limit ay papunta lamang sa 1 over p minus 1, which is a real number. Thus, by integral test, a p series is convergent if p is greater than 1 and divergent if 0 less than p less than or equal to 1. From now on, pwede na natin gamitin itong konsepto kapag ang binigay na series ay of the form of a P series. Tingnan natin ang ilang examples sa susunod na slide. We want to determine whether the given series is convergent or divergent. Pag tiningnan natin yung unang item, ito ay isang P series lamang where P is equal to 1/2, which is less than 1. Kaya base sa discussion natin kanina, itong series ay divergent. Similarly, for our second item, P series ulit ito kasi ang n square root of n pwede natin isulat as n raised to 3 over 2. Kaya P equals 3 over 2 which is greater than 1. And so the series is convergent. Sa pangatlong item natin, sa unang tingin mukhang hindi ito P-series, kaya isusulat natin ito as a summation of 1 over 3 to the n plus 1 over n cubed. Maihihiwalay natin ito sa sum ng dalawang series. Yung una ay summation ng 1 over 3 to the n at ito ay convergent dahil ito ay isang geometric series with r equal to 1/3. Yung isa pang series ay isa namang P-series where P is equal to 3 which is greater than 1. Kaya ito rin ay convergent. Since the sum of two convergent series is convergent, then item number 3 is also convergent.